Types of chemical reaction. Depending upon the type of changes taking place, chemical reactions are classified into 4 types, namely combination reaction, decomposition reaction, displacement reaction, and double displacement reaction.
Welcome to the virtual laboratory. Here are a few experiments that will help you understand the types of chemical reactions. Caution: observe carefully the way these experiments are carried out. Note the methods of handling the apparatus, smelling the gas, identifying the gas, heating the sample over the flame, and procedures followed. Combination reaction. Combination reaction. Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass. Burn the magnesium ribbon, keeping it as far as possible from your eyes. You will observe that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Let us look at another example of combination reaction. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime or calcium hydroxide, releasing a large amount of heat. In this reaction, calcium oxide and water combine to form a single product, that is, calcium hydroxide. Decomposition reaction. Take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note the color of ferrous sulfate crystals. Heat the boiling tube over the flame of the burner or spirit lamp. Observe the color of the crystals after heating. Have you noticed that the green color of ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. Ferrous sulfate crystals lose water when heated and the color of the crystal changes. It then decomposes to form ferric oxide, sulfur dioxide, and sulfur trioxide. Ferric oxide is a solid, while sulfur dioxide and sulfur trioxide are gases. Let us take a look at another example of decomposition reaction. Take about 2 grams of lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. What do you observe? You will observe that the emission of brown fumes. These fumes are of nitrogen dioxide. Here, lead nitrate decomposes to form lead oxide, nitrogen dioxide, and oxygen gas. Let us look at the third example of decomposition reaction. Take about 2 grams of silver chloride in a china dish. Note its color. Place this china dish in sunlight for a while. Observe the color of silver chloride after some time. You will see that the white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked A and B.
In each test tube, take about 10 ml copper sulfate solution.
Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. Also compare the color of iron nails dipped in the copper sulfate solution with the one kept aside. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Double displacement reaction.
Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution.
Mix the two solutions. You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction.
Now let us study the oxidation and reduction reactions.
Oxidation and reduction. Heat a china dish containing about 1 gram of copper powder. You observe that the surface of copper powder becomes coated with black copper oxide. This black substance is formed because oxygen is added to copper and copper oxide is formed. This is an example of oxidation reaction.
Gain of oxygen or loss of hydrogen is termed as oxidation. Reduction means loss of oxygen atom. Look at the examples given below. In these reactions you see sodium and magnesium are oxidized. Look at the second equation where copper is reduced. However, there are certain reactions that do not have either hydrogen or oxygen, yet they are termed as oxidation-reduction reactions. Copper reacts with iodine to form cuprous iodide. To better understand these reactions, we introduce new concept of oxidation and reduction. According to the new concept, oxidation and reduction is termed as gain or loss of electrons. The above reaction can be written in 2 steps, where copper reacts with iodine. Step 1. Copper loses 2 electrons to form a cation. 2. Iodine accepts 2 electrons to form an anion. This is a reduction process. Thus, accepting electron is reduction, losing of electron is oxidation. Oxidizing and reducing agents. The substance that oxidizes other substance is called oxidizing agent. During the process, the oxidizing agent itself gets reduced. The substance that reduces other substance is called reducing agent. During the process, the reducing agent itself gets oxidized. Look at the example above. Copper reacting with iodine. Copper is a reducing agent as it loses 2 electrons and iodine accepts them. Iodine becomes an oxidizing agent. Such reactions where oxidation and reduction both occur simultaneously is called redox reaction.
Summary. Chemical formula of a compound indicates the number of atoms constituting it and number of each constituent element. Molecular compounds are formed by covalent bonding. Depending upon the type of changes taking place, chemical reactions are classified into 4 types, namely combination reaction, decomposition reaction, displacement reaction, double displacement reaction.
Learning surely is a great experience. So, keep learning.